Take a look at section 4.3. Solve quadratic equations using the quadratic formula. Okay, so a few things. In order to use the quadratic formula, you must have your quadratic equation in standard form. In other words, everything has got to be on one side, have it set equal to 0. Why? Because you need to pull out the coefficient of the x squared term, that's the a, the coefficient of the x term is b, and the constant or the number is c. And if you don't have it in standard form, your signs will be off, which is going to throw it off. So step one is make sure it's in this form. Step two is you're going to have to know and memorize the quadratic formula. Okay, and so it's not hard, but you do have to memorize it. Okay, and again, the a, the b, and the c are the coefficients, and we're solving for x. The quadratic formula always works for every quadratic equation, but it's not the easiest to work with. So this is not necessarily going to be your first choice. So for example, down here they talk about we should try to factor first. If it's easily factorable, do that. It's a fraction of the time and less likely to make an error. Then the second choice, you could use the square root property, whether it be just a quadratic that only has an x squared term in it, where you could just isolate the x squared term, take the square root, or if it's in this form, you can see this is the form we get when we complete the square. So if you do completing the square, if it's conducive for that, this would also be easy. But last choice is the quadratic formula, only because it's error prone and it's just longer. But it works for every type of equation. So just to illustrate this, I'm not going to go through this, but here's three identical problems. First one I solved by factoring, right? I removed the greatest common factor of 2, divided everything by 2, and then a simple factorization, I get 3, -1. Here I divide out the 2 again, divide both sides. This is easily done with completing the square. Half of 2 is 1, 1 squared is 1, so by adding 1 to both sides, here I get a perfect square, trinomial, equal to 4, and then take the square root property, right? Take the square roots of both sides, and then you get the same answer of 3 and -1. Now with the quadratic formula, you can divide out if you want the 2's, but it somewhat doesn't matter because you're just plugging in values and punching them on your calculator. So if I put a 2 in for A, so here's a 2 and here's the 2 in the location. The B is a -4. Now notice that the -4 is not the sign, that minus sign is in addition to the -b, the minus sign that comes with the formula. So this will ultimately be a +4, right? And then remember, it's always plus minus, and then b squared. So whether or not you put the negative sign in for b doesn't matter because you're going to square it. It's always going to be positive. -4ac. Be careful with your signs. The biggest mistake are people will mess up the signs for what's next. I'm multiplying 3 numbers and I have 2 negative signs in front of the 3 numbers. An even number of negative signs means that the answer will be positive. So here's the positive. So if you're not careful, that's another source of an error. And so you clean up this radical, right? So you add those up, you get 64, take the square root of 64, and you get a ±8. Now you have 2 problems, right? You have the 4 plus the 8 divided by 4, which is 3, and the 4 minus the 8 divided by 4, which is equal to the -1. Okay, so you can see, easy, pretty easy, more work, not hard, but just more work, more likelihood for an error. Okay, so here, let's just take a quick look at a problem. So if you are asked to come up with a solution for x, the easiest thing is this is factorable, right? So you do x plus 8, x plus 6, factors of 48, 8 and 6 that add to 14, and then boom, you're done. Very little work. So you could pause this if you haven't done this before and try using the quadratic formula. I'll show the solution, but I'm not going to necessarily go through the whole thing. But you should end up with -8 and -6. Okay, hopefully you've worked it out. I'm not going to again explain everything. It's pretty straightforward. There's my A, B, and C substituted in. When I get it down to this point here, it's really going to be two problems. Minus 14 plus or minus, and of course the square root of 4 is a 2. So here is the minus 14 plus 2 divided by 2. Here's the minus 14 minus 2 divided by 2. And when I finish these off, I get the same answer of negative 6 and negative 8. This would be the typical problem that you would use the quadratic formula because it's not factorable. It's not conducive to completing the square nor the square root property. So it's really your only choice. So if you have A is negative 2, B is 5, C is 2, and you substitute it in, you're gonna go ahead and work it. What I want to highlight is the answer and the simplification. Just ignoring this bottom, you're going to get, if you keep the plus minus, you're going to get minus 5 plus minus square root of 41 over negative 4. This may not be considered to be simplified for this reason. This negative 4 is the denominator for both the negative 5 and this plus minus square root of 41. So if I break that into the, again, the individual denominators for both of those, a negative divided by a negative is going to be a positive. The plus minus, the negative 4 divided into the negative 4, again, it can flip this positive, but because it's a plus negative, you can just change this also to a plus 4, and that plus minus is still valid. So the bottom line is, especially in this lead, if your signs can be simplified, if you got two negatives, make it a positive, and then change this to positive. The plus minus handles that for you. So the simplified answer, if you kept it in as 1 is 5 plus or minus the square root of 41 over 4. And that's two solutions right there. So the simplification can sometimes be a challenge. The next problem, I'm not going to go through it, but if you're going to solve this, if you didn't have the minus 5, then it's factored and you can set each factor equal to 0. But this minus 5 doesn't allow you to do that. So you'd have to go ahead and distribute, do your FOIL, and create a new quadratic equation. So if you do your FOIL and subtract the 5, here's the equation that you would get. And then you have your A, your B, and your C, and I'm not going to take that one any further. I'm just trying to illustrate what to do. This problem here, we've from the very beginning of the class, we emphasized equations with fractions. We want to get rid of the fractions by multiplying both sides, which results in everything being multiplied by the LCD. In this case, it's 8 is the LCD, and when you multiply everything by 8, all these denominators will cancel. 4 divides itself. 4 into 8 is 2. 2 times a negative 1 is a negative 2. And down the line, 4 goes into 8 twice. 2 times negative 3 is negative 6. And 8 goes into 8 once. And so therefore you have this. Now one thing you can do is you can divide or multiply both sides of this equation by a minus sign. Because if you have all negatives, or mostly negatives, sometimes it's easier to work without negative signs. You're less likely to make a mistake. So you don't have to do this, but I would look at this and go, hey, maybe I'll just multiply everything by a negative 1 and just flip all the signs so that all the signs are positive. Okay, now when you get this down to an answer, this will have to be simplified for sure. You're going to get x is equal to 6 plus or minus 2 square root of 7 over negative 4. And so again, this negative 4 is the denominator individually for both of these. So if you broke it into the two parts, this fraction reduces to that, and 2 over 4 reduces to 1/2. And again, you still have that plus minus, and so you can get rid of the negative sign here in the denominator because it's being covered when you flip the sign up here in the plus minus. And so this could be the answer, or if you wrote it as a single fraction, it'd be minus the 3 plus or minus square root of 7 all over 2. That would be considered your two answers. Okay, that's it for the quadratic formula. I didn't do a lot of them. This is just a calculator drill. Again, standard form, plug in your A, B, and C. Just be careful with, just do it a piece at a time. Be very methodical. Okay.